Welcome back, friends, to this video. So we are going to talk about loop of Henley. The loop of Henley, it is divided into three segments. We have the descending limb, the thin ascending limb, and the thick ascending limb. So we are going to see the substances that have been reabsorbed in these segments and how they are being reabsorbed. So let's start off the descending limb. About 25% of sodium is being reabsorbed in the descending limb. But the descending limb is known to mainly reabsorb water using aquaporin 1 as a channel. Sodium is being reabsorbed using epithelial sodium channel. The most driving force for the reabsorption of water in the descending limb, it is the increase in the osmolality of the interstitial fluid. The increase in the osmolality of the interstitial fluid, it is because of the continuous reabsorption of sodium and chloride in the thick ascending limb, of which we are going to see how it is being done. So following sodium and chloride, water is continuously reabsorbed in the descending limb in order to equalize the osmolality between the interstitial and also the renal tubule. So this is the segment of descending limb showing water moving out of the tubule into the interstitial. Also sodium, it is being reabsorbed using epithelial sodium channel, which are located at the apical surface of the lumen of the tubule. The water, it uses the channel known as aquaporin 1 to be reabsorbed. So sodium, it is passively reabsorbed. This means that it doesn't use ATP for it to be reabsorbed. So let us now consider the thin ascending limb. The thin ascending limb, it is impermeable to water because it doesn't have aquaporin channels, but it can reabsorb sodium and also chloride. Also these, they are passively reabsorbed, which also mean that they can't use ATP. So sodium is reabsorbed using epithelial sodium channel, which are located at the apical surface of the lumen. Then chloride, it uses chloride channels to be reabsorbed. So this is how sodium and potassium is reabsorbed in the thin ascending limb. So sodium and chloride can also use paracellular process when being reabsorbed. This paracellular, this is when the substance are being reabsorbed using the space between the cells. So for paracellular, the substance doesn't need to use a channel. It just passes through, passing between the space that is between the cells. So now this is the diagram showing the thin ascending limb. So from this ascending limb, we have sodium channels, which are epithelial sodium channels. We have also chloride channel. So we can see between those are the cells. Between there is a space which sodium and also chloride use to pass into the interstitial. Then that's the epithelial sodium channel, which is used to reabsorb sodium into the interstitial. Then the one at the middle, it is the chloride channel, which is used to reabsorb the chloride, which is the chloride channel. So we can see all this moving into the interstitial, increasing the osmolality of the interstitial. This acts as the driving force to reabsorb water using the descending limb of the loop of Henley. So that's how it is done. So the next one is the thick ascending limb. The thick ascending limb, it is also impermeable to water, but it can reabsorb sodium, potassium, calcium, magnesium, and chloride. Sodium, potassium, and chloride, they use one channel whose driving force is sodium potassium pump. So this sodium potassium pump, it is located at basolateral of the tubule, which allows 3 sodium to move out of the cell, creating chemical gradient. This chemical gradient that it creates, it causes sodium to go back to the cell, the sodium which is in the lumen, together with potassium and 2 chloride. So let us just now see the sodium potassium pump, which is located at basolateral. So this is the channel sodium potassium pump. It lets 3 sodium to move out of the cell and 2 potassium to move into the cell. So remember, this sodium that is moving out of the cell, it is not the one that is in the lumen. So the movement of this sodium, it is creating the sodium chemical gradient, which in turn, now the sodium which is in the lumen, the ability to go into the cells of the epithelial of the lumen of the tubule. It doesn't go alone, but it is being reabsorbed together with potassium and chlorine. So 2 chloride is being reabsorbed, 1 potassium is being reabsorbed, and also 1 sodium is being reabsorbed using the channel NKCC2. So this is the channel that it uses. Then calcium, magnesium, and also sodium, they are being reabsorbed using paracellular, which is in between the cells. They pass between the cells into the interstitial fluid. So this is how they are being reabsorbed. Thank you, friends, for watching the video. Don't forget to subscribe and share.